Which of the following sets of quantum numbers is invalid, right? So remember that there are 4 quantum numbers which are actually used to describe the probable position of an electron, right, around a nucleus. Now, the first quantum number, which is n, that's the principal quantum number. And n can range from n is equal to 1, which corresponds to the first period here, that's n is equal to 1, onwards, right? So for each subsequent period, you add in another n. So this can be n is equal to 2, this is n is equal to 3, etc., right? So for all of these answer choices, the n is valid, okay? It could be, the electron could be in any of those n values, okay? Now L, okay, is the angular momentum quantum number. So angular momentum. And n can range anywhere from 0, right, to n minus 1. To n minus 1, okay? So it can never be equal to n. It always has to be one less than n. And by the way, L basically describes the shape of energy subshells, right? So like the s orbital, which has a spherical shape, the p orbital has like a dumbbell shape, etc. So if we look at these answer choices, right, all the n's are valid. But then if we look, L is equal to 1, that's possible for n is equal to 3 because it ranges anywhere from 0 to n minus 1. B, L is 3, again, that's possible. But then C, and L is 2. And L is 2 is equal to n is 2. So 2 is equal to 2. But that's not possible, right? The maximum L value for n is equal to 2 is L is equal to 1, right? Because it's n minus 1. So C has to be invalid right away. Let's just cover the other 2 quantum numbers though, right? So M1, right, which is the magnetic quantum number, okay, or ML, right? This can range anywhere from negative L, right, to positive L, right? So to positive L, to the maximum L value. So from the negative of the maximum L to the positive of the maximum L. So for example, if L was equal to 2, okay, then ML could be anywhere from negative 2, it could be negative 1, it could be 0, it could be plus 1, it could be positive 2, right? It could be any of those. That's how you would describe it, okay? And again, if you look at these, like L is equal to 1, ML could be 1, L is equal to 3, ML could be negative 3, L is equal to 2, it could be 1, and then 0, 0, right? That all adds up, okay? If L is equal to 0, then the only value of ML could be is 0, okay? Now MS, okay, is the spin quantum number, and this one is nice and easy because it could only be positive 1/2 or negative 1/2. And of course, all of these are therefore valid, okay? But the only invalid set here is C.